In collaboration with jetpack manufacturer Gravity Industries, Domino's Pizza has become the first company to deliver pizza using jetpacks, striding boldly into the future of food delivery. The custom-built jet suit worn for the delivery is still in the thousands of dollars, illustrating the experimental nature of the endeavor. The delivery was initiated as a pilot project at a music festival in Glastonbury, UK, where a drone pilot had to assume the role of a traditional Domino's driver. He scoped the pizza from a drone at a nearby Glastonbury location, flew over the fields, and dramatically dropped it off for festival-goers to claim, capturing the imagination of several onlookers. While questioned if jetpack delivery will become a standard practice at Domino's, a company representative responded rather ambiguously. "At this stage, all we can say is the idea is anything but grounded, or maybe has legs, wings, or a jetpack." This statement hints at the fact this is a work in progress, but illustrates the boundaries set for future developments. The company has also noted this is the future of fast delivery service, which indicates they foresee high potential with this technology. As it stands, the current application is more of a publicity stunt than useful, but it does demonstrate how technology can be used to tackle pre-existing problems in the delivery industry. Novel approaches to food delivery, such as the jetpack delivery system, may one day be suitable for remote regions and emergencies. Engineers at Gravity Industries have developed an innovative jet-powered suit known as the Jet Suit, a groundbreaking personal flight system that pushes the boundaries of human mobility. The Jet Suit is designed to have 5 mini turbojet engines which consist of 2 on the arms and 3 at the back. This enables the suit to reach speeds of up to 88 kilometers per hour and ascend to an altitude of 3,658 meters. The suit provides unparalleled freedom of movement. However, the flight time is limited to around 5 to 10 minutes based on conditions and weight, making it more suited for short-duration missions like military ones. The suit controls speed and precision through arm and body movements, which require significant training to achieve mastery over. The suit caught the attention of experts and was showcased at the Special Operations Forces Industry Conference, who noted the military and rescue application potential the suit had. When perfected, the jet suit can be utilized for swift penetration of enemy territory, obstacle circumvention, reconnaissance in regions with limited access, and emergency scenarios, making it a game-changer for wars and rescue missions. Even in its experimental phase, the jet suit marks a significant advancement in personal flight technology and has the capability to change how we think about mobility in difficult terrains. Its speed, agility, and versatility make it a useful asset for military and civilian applications alike. Here is the Flyboard Air, the latest jet-powered flying platform developed by French inventor Frankie Zapata, which may soon be adopted by NATO soldiers. The device is a hoverboard equipped with 5 turbojet engines running on kerosene, offering unrivaled lift and rapid maneuvers. The unit has an operating flight ceiling of 3,000 meters, top speed of 150 km per hour, and can carry a weight of 120 kilograms. The primary purpose of the Flyboard Air is for individual and stunt flights, suggesting its use in civilian and military operations. Mastery requires the use of torso tilts and a body-mounted controller, demanding a significant heightened level of effort and precision to operate. As of now, the device is not available for purchase and is mostly reserved for military and commercial demonstrations and spectacles where its features can be presented to larger audiences. The cost of the Flyboard Air is not publicly available, but some reports claim that in 2017, Zapata presented the Flyboard Air for US Army consideration with a projected figure of approximately $250,000. Regardless of its astounding features, the Flyboard Air is not widely adopted because of the complex operation, short flying time, and high costs. Nevertheless, the possibilities of transforming personal and military mobility. The world's first commercially available jetpack, the Martin Jetpack, is a product of the Martin Aircraft Company, located in New Zealand. It uses a unique propulsion system that differs from traditional jetpacks. It utilizes a 2.0-liter gasoline-powered V4 engine with 200 horsepower, which drives 2 ducted fans. This allows it to attain speeds of 40 kilometers per hour, an altitude of 760 meters, and maintain flight for almost 28 minutes. For short-distance travel, this jetpack is practical. With an empty weight of 200 kilograms, the Martin Jetpack achieves remarkable performance capabilities. However, the weight remains on the higher spectrum. Initially, the company marketed it as a device for recreational flying, but it quickly turned into an emergency response device utilized in search and rescue operations as well as military missions. Its ease of use allows it to be utilized in hard-to-reach areas during times of disaster, making the jetpack a valuable asset for tactical missions. The development of the Martin Jetpack, which is still in the early phases of development, highlights the potential of personal aviation. It provides an insight into the prospective future where civilian and professional jetpack usage could turn into commonplace transportation. Alf Aeronautics, an American aviation company, showcased its flying car for the first time, claiming it can soar up to 110 kilometers. During one of the tests, the Alf car was able to fly over traffic that was at a standstill, demonstrating its promise for urban mobility. This was an emergency and traffic blockage. The ultralight version of the Alf Aeronautics flying car was tested by flying over a closed road in a sparsely populated area, demonstrating its ability to seamlessly shift from ground to aerial travel. This vehicle has been granted flight permissions in US airspace, a mark of progress in personal air transport. The ultralight Alf is capable of driving around 322 kilometers without needing to recharge, while also having the capacity to fly 177 kilometers, making it ideal for medium and short-distance journeys. Additionally, the car features a parachute for emergencies, ensuring the safety of the passengers in the event of unforeseen problems. According to company CEO Jim Duchovny, thousands of pre-orders have already been made, which reflects the demand for this new vehicle. Within the next 12 months, Alf Aeronautics hopes to initiate production in anticipation of releasing this mode of transportation to the public market. The company also reports that the cost of the vehicle will be around $300,000, making it a premium brand for first movers. SkyDrive, a Japanese startup, has created the SD-03 flying car, which is an advanced prototype of urban mobility technology. The SD-03 is a one-person seat, vertical takeoff and landing, VTOL air vehicle with 8 electric motors. It is designed to execute autonomous low-altitude, speed, vertical flight. The SD-03 is 4 meters long, 4 meters wide, and 2 meters tall, making it compact. This makes it easier to navigate in urban settings and use current infrastructure. The air vehicle's electric drive system has an optimal energy consumption and emission output, which is in line with the modern-age environmental standards. Its electric drive systems guarantees optimum energy consumption and emission output. Additionally, the SD-03 is capable of vertical takeoff and landing, which makes it usable on rooftops of buildings or specialized landing pads. Emphasis is being placed on safety issues by incorporating redundancy and automatic flight control. Here is a breathtaking joint flight of the Jetman Dubai team and the Breitling Wing Walkers group over Dubai, a spectacle that has, without exaggeration, amazed the entire world. The collaboration between Jetman and the wing-walking planes involved a breathtaking adaptation of aviation technology that fuses new with old by jet wings of the Jetman and classic planes with acrobatic wing walkers. Jetman Dubai is a team of air enthusiasts founded by the Swiss pilot and inventor Yves Rossi. He developed the individual jet-powered wings, or a device that works autonomously, enabling humans to achieve avionic reality of flying like a bird, which has a maximum speed of 407 km per hour, flight altitude of 6,100 meters, and a range of 50 km. With these figures, the free world of aviation gives an unrivaled experience of the stunning stunts and complex maneuvers enabled at high speeds. In the video, the Jetman Dubai team, together with the Breitling Wing Walkers, are performing a flight in the most beautiful places and landmarks of Dubai. This venture represents the integration of cutting-edge technology and classic aviation practice, displaying the potential of human capabilities in flight and aerobatics in an astonishing manner for people around the globe. As an important milestone in engineering and technology, Jetman's wings unlock the possibilities of individual aviation, and the acrobatics of wing walking pays tribute to the pioneers of aviation. If aircraft continues to strive to make air transportation as simple and accessible as possible for the average person. Its most notable development to date is Hexa, a compact electric drone lifted into the air by 18 rotors. According to the company, the device can be flown without any prior training or a pilot's license, only requiring voice commands. The drone-style aircraft can maintain a cruising speed for 15 minutes on a fully charged battery and will automatically land and shut down if not piloted within that time frame. In the event of one or more motors failing, Hexa is still capable of smoothly landing using the propulsion of the remaining rotors. Although it is highly unlikely that all rotors will fail simultaneously, Hexa is equipped with a ballistic parachute to soften the impact of a crash. The drone is also capped at a set maximum altitude to ensure safe flight paths of other aircraft. This is one of several reasons why no pilot's license is needed. Altogether, they significantly lower the barrier to flying the Hexa drone. In partnership with Toyota, Joby Aviation has released a revolutionary electric flying vehicle that could change how people travel. Unlike its predecessors, among the N542's awe-inspiring attributes is its unparalleled performance and energy efficiency technology due to its aerodynamic features. The maximum speed of the N542JX is 320 km/h, and its flight range at cruising speed is approximately 240 km, categorizing it as a mid-range capable aircraft. N542JX is unique and stands out due to its fully electric propulsion system with no carbon footprint, making it eco-friendly in comparison to conventional vehicles. Further, it is engineered for low operational acoustic noise, which is an advantage for urban environments riddled with traffic. The N542JX is ideal for passenger and cargo flights and emergency services. The zero emissions capabilities and the innovative design of the N542GX have major implications for the urban transport systems in the future, enabling cleaner, non-polluted, soundless ecosystems for efficient transportation on the ground, air, and within the city. It seems that the Japanese are very serious about changing the game in cargo transport with Kawasaki's development of the K-Racer X1. The K-Racer X1 is autonomous VTOL aircrafts, vertical takeoff and landing, which gets its power from a supercharged 1000cc engine from the Ninja H2R motorcycle, yielding 310 horsepower. This allows it to perform exceptionally well, while maintaining a payload capacity of up to 100 kilograms. The aircraft is specifically made to solve logistical problems in access-constrained areas like mountainous regions and disaster-stricken zones where deliveries are virtually impossible with traditional delivery systems. The K-Racer X1 can travel distances of 100 kilometers at a speed of 140 kilometers per hour, which makes it a highly proficient machine for rapid cargo deliveries. Besides these features, Kawasaki has added a robotic assistant for the automated loading and unloading of goods onto the delivery system. In 2024, the company showcased the upgraded version, K-Racer X2, which has additional enhancements of increased rotor diameter and up to 200 kilograms of payload capacity. The Northeast Electric Company, NEC, has recently made a notable flight mobility advancement by developing a prototype of a flying car. This advancement marks a milestone for air mobility during this period. The helicopter-like vehicle prototype has an astonishing weight of 148 kilograms, with a compact height of 1.3 meters, a width of 3.7 meters, and a length of 3.9 meters. During tests conducted at NEC's test site, the vehicle demonstrated the capability to lift itself off the ground for 3 meters and hover mid-air for several minutes. Unlike traditional cars, the vehicle has 4 turn rotors, which gives it a striking resemblance to a large quadcopter. At this stage, it would be too early to label it car. While it does possess 3 miniature, stowable wheels, its ability to maneuver on roads, achieve high speeds, or even drive is still untested, and makes any assumptions about its functionality premature. Flight test footage depicts the machine wobbling noticeably while propelling, indicating the ongoing challenge of maintaining stability, but also showcasing the independence of the vehicle. Although there were issues that needed to be addressed, the mere fact that the vehicle was able to lift off indicates that there is potential in the area of flying cars, which in turn suggests that advancements in aviation technology will happen in the future. Aeronex, a company from Japan, has unveiled an interesting new aerial transport concept, the flying gondola. This prototype is a hybrid electric vertical takeoff and landing eVTOL vehicle that is built considering safety, comfort, and innovation. Unlike other aircraft prototypes, the flying gondola has unique design features related to control of the vehicle and structural engineering. One of the distinguishing features of the flying gondola is the attention put on stability and comfort level of passengers while flying. This is achieved through the 4D gravity technology, which controls the vehicle's center of gravity. This technology greatly reduces vibrations, providing a smooth and comfortable ride. In addition to the advanced gravity control system, the gondola has inclined wings and 8 adjustable propellers that can enhance flight performance. The initial prototype is configured to transport 1 passenger, although future models are planned to expand the potential market by accommodating several passengers. The design also takes into account ease of vertical takeoff and landing for the vehicle, which is important when operating in urban areas with space constraints.